Today we will learn about Floodfill algorithm. It is a core concept in computer graphics for area filling, segmentation, and graph traversal. In this video, we will see the introduction and application of Floodfill algorithm and how it is implemented by 4 connected pixel and 8 connected pixel and their comparison and drawbacks. What is floodfill? Floodfill algorithm is fundamentally used for filling a connected area of pixel with a specific color or pattern. It operates on a principle of connectivity to define the region to be filled. It starts from a single pixel known as a seed point. It checks the color of a seed point, the old color. It recursively or iteratively changes the color of all adjacent pixels that also match the old color to a new fill color. The flood stops when it encounters a pixel that is not the old color. Real-world applications of flood-fill algorithm are in image editing. The primary use is the paint bucket tool in all major graphic design and editing software to quickly recolor large contiguous areas. For example, we all have used paint app in our childhood when we used to draw circles and rectangles and then we were used to fill it with colors. The same algorithm is used there to fill the colors. And it is also used in game development and image segmentation too. One way to implement flat fill algorithm is by 4 connected pixel. The 4 connected method is the simpler form of connectivity, checking only neighbors that share common edges with the current pixel. The neighbors checked are north, south, east and west. Diagonal pixels are explicitly ignored and are not considered part of the connected region. It is generally faster to compute due to fewer checks but may leave uncolored gaps along the diagonal boundaries. As we can see in this picture, the blue squares are not the neighbors, only the white ones that are top, bottom, left and right are used to expand the colors. That is why it is called as 4 connected pixels. Here we have function for 4 connected flood fill algorithm. This algorithm uses recursion where the function calls itself on the 4 valid neighbor coordinates. This process is repeated until the border is reached. Here our function has 4 arguments x, y which are our coordinate of original pixel and fill color with the color which is needs to be filled and old color of the polygon. When we look at our code, then first we will get the color of our original pixel and match it with old color. If it is valid, then we will set the color of the original pixel with the fill color, and then we recursively call all the neighbors of it that are top, bottom, left and right, and they will recursively call the other neighbors of it, and that's how our 4 connected flood fill algorithm works. We can implement floodfill algorithm with 8 connected pixels also. In the 8 connected method expands the connectivity criteria to include all neighboring pixels whether they share an edge or just a corner. It checks the 4 direct neighbors and the 4 diagonal neighbors also. It ensures a more complete fill and is necessary for shapes with complex or thin diagonal structures. The trade of slightly increased computation time due to checking 4 additional pixels for every single point. As we can see in this picture, in the 4 connected pixel we only use the top, bottom, left and right, but in this we also use the diagonals also. So here we have 8 neighbors. Before previous we have only 4 neighbors. Here we have a function for 8 connected flood fill algorithm. It is almost the same as the 4 connected flood fill algorithm. If we look at the argument of the function, there were 4 arguments. Here we also have 4 arguments that are same argument. The only difference is that here we call 8 neighbors. We also call the diagonal neighbors too, and the top, bottom, left, right also. So here we call 8 neighbors recursively, and that 8 neighbors also called 8 neighbors recursively, and that's how the 8 connected floodfill algorithm works. Here we will see the difference between 4 connected and 8 connected floodfill algorithm. In 4 connected approach, horizontal and vertical neighbors are called, but in 8 connected approach, horizontal, vertical and diagonal neighbors are also called. Performance wise, 4 connected approach is simpler and faster, and 8 connected approach is complex and it is slightly slower than 4 connected approach. But in accuracy, 4 connected approach is less accurate and 8 connected approach is more accurate. Alternative approaches and optimization. Scanline fill. An iterative optimization that fills continuous horizontal segment only pushing the next segment seed pixel to the stack. This drastically reduces cost and is cache friendly. Iterative. Using an explicit stack or queue to manage unvisited pixels, this avoids the risk of system level recursion, stack overflow for very large regions. Boundary fill. a related algorithm where the fill process continues until a specified boundary color is encountered rather than checking against an uniform old color for the region's interior. Challenges of recursive implementation. For very large or complex areas, especially in high-resolution images, the recursive approach is prone to hitting the operating systems or programming environment's recursion depth limit, leading to a stack overflow error. Non-recursive methods like scanline fill are preferred in production environments. Thank you guys for watching. If you have any questions, please comment below.